I am going to discuss today about isocyanate. This is the structure of the isocyanate. Let us look what is the hybridization and bonding structure of the atoms present in isocyanate. Now you can see nitrogen, carbon and oxygen are present. This can be alkyl or aromatic. At the moment we are not going to discuss that because it will be too much complicated, because there can be wide varieties of possibilities for this R group, because it belongs to most probably an organic group. In nitrogen, we can see one lone pair and two sigma bonds and one 5 bonds. According to the VACPR theory, there are 3 repulsion units. Then this would be sp2. When we come to carbon, there are no lone pairs, 2 repulsion units. Then this would be sp. When we come to oxygen, again 3 repulsion units. Then it should be sp2. Now it is clear nitrogen and oxygen have same hybridization here. Now we can move into the synthesis of isocyanate. We need primary amine, and this can be reacted with phosgene. You can see COCl2 at very low temperature, because this is very vigorous reaction. Here amine reacts or acts as very strong nucleophile, and phosgene react as the electrophile. Using this reaction we can easily get the isocyanate. Isocyanate is stable, but they are highly reactive towards the nucleophile, and with 1 to 2 days it is possible to decompose to other byproducts. Now let us see the mechanism behind this synthesis reaction. Now strong primary amine attack the carbon like this, and the first formation of the bond can occur. So we have to understand that chlorine is very good leaving group here, and it can leave in this way. Then I am going to draw here now one of the proton can be extracted by this chloride dye. This can result this is actually not isocyanate, it is a intermediate product. In the next step the required isocyanate will form. Now we have to think what is the next step would be. There's a lone pair on nitrogen atom and 2 lone pairs on oxygen. Also there are 3 lone pairs on chlorine. The lone pairs on chlorine atom are not much important here. This lone pair on nitrogen atom can delocalize with the carbonyl group and form this intermediate. It will result positive charge on nitrogen atom. Then this negative charge again come back, but not the earlier arrangement. That means it doesn't come there. Instead of that, chlorine atom will leave. Again, that chloride ion can take the proton from here. It finally results isocyanate. So this mechanism is very important. There are several steps you have to go through and to understand. But this will happen very quickly. So we have to maintain 0 degrees Celsius. Otherwise, unwanted byproducts can form. Now we will look what are the reactions of the isocyanate. Mainly we can see isocyanate easily react with amines and alcohols. That means they both are nucleophiles. With amines, they undergo very easy reactions. That means even at 0 degrees Celsius. But with alcohol, we have to use somewhat higher temperature, something like 50 to 60 degrees. This is because amines, that means primary amines, are strong nucleophile than alcohol. So these are the resultant product. If you treat isocyanate with amino alcohol, in the next step we will see how these mechanisms are created. It is important to understand what is the reaction center of the isocyanate. This is the main reaction point because this carbonyl carbon can delocalize or polarizes so that oxygen get negative charge and carbon get positive charge. This will give the opportunity to nitrogen atom for attacking as a nucleophile. Now this is the first step. So you can see it create a cationic charge on nitrogen atom. So we have to complete the next step. In the next step, one of these proton will remove and attach on nitrogen. This nitrogen should contain lone pair. This way. So this is urea related product because two nitrogen atoms have attached to carbonyl carbon. Now this is how isocyanate react with alcohols exactly as they do with amine. So I am not going to explain that. So you can see the mechanism. Alcohol will act as a nucleophile and attack carbonyl carbon and go to the intermediate step and finally to this structure.